But yes, all right. So we'll ask Ethan to do a short demo. So let me do a quick recap. The announcements has the short videos. One thing that I have to say is our current LMS system that I'm using does not allow for the easy attachment of the video files. So working within Canvas has been phenomenally easy in terms of being able to shoot a short video to show people how to do things and then tag that on. I happen to use Snagit, S-N-A-G-I-T. Jing was the one that they're actually the same manufacturer of Jing. It's TechSmith. And it's just a really simple, low cost. They have education rates also, where it's pretty darn cheap to create and edit and make your own videos like that for screen capture. So just be aware that there's a lot of free tools out there and stuff that you can also use. But the Canvas operating environment, and again, it's free. You can get a free Canvas account. Is an easy way to have your students post information, and then you're able to attach that video. All right.
Oh, Tom, I was going to add, I've been using Zoom just for recording my little help videos as well. You can just share your screen and make a little Zoom meeting, share your screen, and save it away. So that's pretty easy to do.
Yeah, like I said, Snagit is a pay product, but it does work really well, and it is fairly low cost. All right. So Ethan, would you like to do a demo on, I guess you can split it up into two sections, maybe about the setup process first, and then we'll go from the setup process into the toolpath process.
Sounds good. So I'll start sharing my screen right now so you guys can see what I'm working with. All right. Does that look good?
It sure does.
So one of the first things, right now I'm in the design workplace. I've got my profile all made and my body's cut out. So one of the first things you want to do is switch over to the manufacturer tab. And then up here is the tool library. It's a lot easier to set all your tools first as you start out, get all your feeds and speeds and all your diameters all set from the get-go. Is that pop up? Can you guys see the tool library pop up?
Yep, your tools are listed now.
Awesome. Cool. So I find it easiest to go and to the local tab here, and you can right click on the local tab and start a new library. But this is all the tools that we have on our machine right now. So I'll go and then I'll rename the new library. Then you could name this as your machine and then work from there. So the first thing we want to do is add a new tool. And for the most part, it really depends on your machine, but you're probably going to be working with a 1/4 inch or a 1/2 inch end mill. But for this, we'll do a flat end mill, and we'll start with a 1/2 inch end mill. So the description, you kind of want to go and just give a little bit of info about your tool there. I'm just going to do a 1/2 inch end mill. And then you can set your cutter diameter, which is all in millimeters right now. And your shaft length. And this all depends on the tools you use. It's going to be different for every tool that you get, really.
So when you go out and purchase the tools, you can actually get this information from your manufacturer.
For the purposes of us doing it just digitally, like what should we put in there?
The info from your from the tools that you get from the manufacturer.
I think the question was, though, for right now, for hypothetical, if they don't have a tool, what should they make up to stick in there as a hypothetical tool?
A 1/2 inch end mill will be great.
Yeah, 3 inch overall length would be fine.
Yeah. you want to make sure that it's thicker, longer than at least 2 inches, or else you're going to get collision errors when it tries to go all the way down. Hold on, 1 second, sorry.
While Ethan's taking a break, I'd like to throw a comment in, and Tom and Steve or anyone else correct me if I'm wrong. But for a lot of people doing this, if they're just going to be cutting out, the body shape and not doing any sculpting, they're probably only going to have one tool in
Yes.
in their list. So just so that's clear for people.
Yes.
Right. Absolutely.
And then the shaft and the holder isn't too important for this right now. It doesn't really affect much for that. And as far as the spindle speed goes, you want to set your speeds and feeds, which for the most part the defaults are usually good, and it really all depends on your machine too, what you're looking for. But it's better to go slower and safer and do a less shallow depth of cut versus trying to hog it all out at once.
So many of our participants may have a regular router that's attached to their CNC. So their spindle speed may be set at like 22,000 RPM. And again, that just depends upon the equipment you're working with. For our demonstration, Ethan set up 10,000 RPM and 40 inches per minute as our cutting rate. And so if you wanted to utilize that for your demonstration, for your project, perfect. If you want to set it up for your CNC machine, you can also do it that way. I just wanted to make sure that you're aware that the spindle speed is dependent upon the type of equipment you have.
And then vertical feed rates, the defaults are usually pretty good. It doesn't get too wild. And then as far as the post processor, these don't matter too much unless you have an automatic tool changer or anything to that degree. So we'll go ahead and accept that. And so we've got our new tool set here right now, and that foot length is incorrect. But it'll be fine because the overall length is longer.
If you wanted to actually look up a tool, you can go to msc.com. I'll put it in the chat. And you can actually look up a 1/2-inch diameter CNC mill. And you can get all the data. You can get a 3-inch CNC mill, and it'll give you the flute length and so forth. So MSC is the manufacturer that we purchase a lot of our tooling from, because it's cheaper than buying it from CNC manufacturers or other locations.
And so for this operation, if we're just doing the profile, we're just going to use this one tool, but you can have as many tools as you use for all different kinds of operations. And it's really nice to have them here in the local drive, just as a one-stop shop. It's when you go to make your tool path, it'll ask you to select a tool, and then you can just pick the tool that you already have set up with all your information set for it. So I think for this demonstration, we'll just do this one tool, but it's pretty much the same process with any tools, any end mills or drills that you would use. So once you have your tool library set, another thing that you have to consider is where the body is going to be located on your machine. For the most part, you can either set up your own specific work coordinate, at the center point of the blank, or you have a known origin location on your machine and you know where that's at. So I'm going to kind of go through and show you how you would set up different ways. So if you have a known origin on your machine, we want to go back to the design, and then on another sketch, I'm going to use sketch 20 because it's already here. You want to set up where you want to make a point to where your origin would be, if that makes sense. And I know on our machine here, the origin of the model right now is set at the very bottom of the neck pocket, but I know that our machine is set up 23 inches to the right, and then it's 30.422 up top here. And so that's just where our origin on the machine is at. If you don't know that specifics and you want to just touch off, mark your blank as in the center of the blank and do that, then you can draw a line. I want to project the 2 dots in the middle right here, so I can draw a line going from those. And then we'd want to create a point at the midpoint of that line, which is what the little triangle constraint means. So if you were to do this, you would take your blank and then measure out the midpoint of that, and then draw a little X in pencil on the machine, and that's where you would set your bit to as the 0, 0 point. And then in this case, I'm going to finish this sketch, and I'm going to go back to the manufacture tab. So here's where we would create a setup in the setup tab right here. So the first thing it's going to ask you is the machine. And this shouldn't be, it'll just be a cutting. We'll do the generic cutting machine here for the setup. And so this work coordinate system tab, this is where those those points that we made in the sketch goes into play. So we want to go into our model here and turn on the sketch that we just made. I'm going to turn off the profile sketch right now so it makes it a little bit clearer. So this work coordinate system tab is going to determine where your origin of your setup is. So right now it's set up as the model orientation of the stock box point. So what it's doing is it's taken the whole shape of that and putting it right in the middle. And we don't want that per se. So we're going to switch to select coordinate system here. And then it's going to ask you, all right, where do you want your origin to be? In that case, we can either put it in the middle of the blank that we know is right here, or where we know our origin to be on our machine through measurements. So I am actually going to select this one. And I did make a little mistake. I'm going to backtrack. I'm sorry. This also determines on the sketch that we made back there, we want to make sure that that's on the top of the blank, because we want our Z0 to be on the top of the body, and it's going to cut down. Whereas you could see that point is on the bottom, and that's not what we're looking for. So I'm going to right click this and redefine sketch plane to be on the top of the blank here. And it kind of moved everything around for some reason, but we'll copy. We'll take that and move it back to where 180. We'll go point to point, and we know that this point was right at that target there. That's very strange.
Yeah, it's almost like it double mirrored it.
Right, it mirrored it, but oh, it mirrored it at the origin, right there. So I'm just gonna redraw that line in the middle. And we'll go back to editing this sketch here. And that is so incorrect. Let's just start from scratch here. Now we know that we're on the top sketch though. You can see that sketch plane is at the top of the body, which is where we want to be.
So fixing errors is one of the big things that we as instructors have to do. So that's perfectly a-okay here, Ethan, to show how to fix stuff, because I can pretty much guarantee we'll be doing that with our students.
Right. And some of the times it's better to, instead of trying to go around and fixing it and manipulating it, just go back to where you know where it started and then resketch it and do it again. Not only does that give you practice in doing it, but it also, a lot of times it's a lot easier to fix stuff that way. So we'll say that we're gonna make the our origin at the midpoint of the blank here. So we'll finish this and then go back into the manufacturer tab. And then since we didn't set that setup, we're gonna need to create a new setup again. It'll be the same setup, but it's that. And we'll, back in the work coordinate system, we're gonna select work coordinate system and select this midpoint, essentially making that our origin for the machine. This is where, this point is where you want your X and Y 0 and Z 0 to be on the machine. So maybe you want to touch off in the corner of the blank, or maybe you have a defined point that you want to use. This is really where it all ties into. So that's correct. Our stock, I normally like to, well, for this, we'll do a fixed size box and actually make it the size of our blank so we can actually see the stock, which is 14 by 22 by 1 3/4. Which that should be lining up. So that'll be roughly where our actual stock is. And the stock doesn't play too much of an important role unless you're going and taking out all this, most of the stock with adaptive passes, but we don't worry about that. And then as far as the program name and number, this is what is going, the name of the file when you post it out is going to be. So we can call this custom body. And then that's when we output the G code, that's what the program name is going to be. And the work coordinate system here, we don't need to worry about for right now. So I'll hit OK. So I'll hide these setups here. And so now we have our setup, our origin is set up and everything's all good to go. So we'll rename this. We'll call this setup custom profile will be this setup. And it's always good to get in the habit of naming things to what they are. It makes it go back, when you're trying to go back and look at it, it makes it a lot easier to know, have a label for everything versus just setup 1, setup 2, setup 3, and so on, and you're wondering what they are. So now that we have the setup made, and that ultimately defines where our origin point in the machine is going to be, we're going to want, we can actually create toolpaths for this setup now. So you can have setups set for example, I'll show you the front and the back here for doing the pockets. I just have the pocket set right here if I can. So you can see that this setup, the origin the Z is facing up, and the X and Y are right there. I want to hide these real quick to make it a little bit clearer. You can see the origin is set up right there, and that's for milling the front pockets here. But for these back setups, it's actually the Z-axis is flipped. You can flip the Z-axis in those setups. So in the work coordinate for that setup, the Z-axis is flipped because you're actually flipping the body over. So you don't want to be cutting the front, and you're keeping that same position in the X and Y value, just cutting it from the back.
So you want the Z direction then to always move out of the body and not into the body as a positive movement.
Yes. And so with our setup for our profile completed, we can actually start making toolpaths on the setup, and we know they're right where we want them to be as far as the X, Y, and Z coordinates. So that's about the basics as far as setting up and getting your tool set up. Does anybody have any questions so far before we start making some toolpaths?
Hey, Ethan, at the start, you chose generic machine. How important is that? Like,
Not very. That's actually a new feature that I wasn't familiar with.
Okay.
Let's just updated the thing.
Thanks.
And actually, I think for this one, I didn't even select a machine after I did that. So very not important. I'm sure that you can work with that and set up your boundaries of your machine, your lengths. But as long as you know that you're within the bounds for this, it's not super important as far as right now. So yeah, we'll start making some toolpaths for the profile now. So for the profile, it's just going to be a 2D contour. I find that's one of the best ones. If you're just cutting around a profile, the 2D contour is the one that you want to use. And so the first tab you see pops up, it's asking you what your tool you want. And so that's when it'll bring you actually back to the tool libraries that we set up earlier. So this is the whole tool libraries. So we can go to our local and your machine, and then we can select the tool that we set up for our machine right there. And that's going to update all the speeds and feeds for that as we go. So that's why setting up the library beforehand makes it a lot easier on the back end when you do that, because you just need to select your tool and then everything's ready to roll. The next tab is the geometry tab. So it's going to ask us for our contour selection. So what we want to do is this will actually be the profile, the shape of the profile we want to cut out. And we want to make sure that we select the profile on the bottom, because if we select the one on the top, you can see that the neck pocket, it's actually going in the neck pocket. So if you select that top edge right there, you won't have a neck pocket left in your guitar. So by selecting the bottom one, it goes through and leaves the shape of the neck pocket right there. So we'll select that one as our contour selection there. And you want to make sure that this red line, excuse me one second.
Well, Ethan is swigging, just in case people who aren't familiar with Zoom enough don't know, you'll see probably images that have defaulted to the upper right corner of the screen with our faces. You can grab that and slide it over to the left, and then you can see the tabs that Ethan is clicking
on. So when you're doing a contour selection, that bit is going to cut on one side of the contour, and you want to make sure that red arrow is on the outside. If you click the red arrow, then it switches positions. So right now, this isn't what we want, because this is going to be cutting on the inside. So we'll click it again so it goes along the outside there. And then another thing on this tab this geometry tab that's important is the tabs tab. For most people, these are bolt-on blanks. It has the holes for the bolts, and you're not double stick taping it to the fixture, or you don't have a vacuum fixture. So it's very important that we create tabs in this profile, or else when it's done cutting, the body will come out, and that's not a good thing. Usually the tab width, I find 1 inch is a good tab width, and about a half of an inch is a good height. And I like to do triangular tabs because it smooths it out when it's ramping. If you do rectangulars, when the bit comes along, it pulls straight up and goes over and goes straight down. And when the bit stops like that, it tends to kind of gouge a little bit versus the triangular ramp slowly. And I find one of the best ways to do it is also at points instead of distance. That way you can select exactly where you want the tabs. And in general, good practice is to select those positions. You can click on the profile. Should be able to click on the profile. Technical difficulties. I'm gonna try opening up our sketch again. Okay, yeah. So you need to have the sketch. You can see the tab there. So you need to have the sketch open for the profile that you're using. So, and good practice for placement of tabs is one on the very bottom, one up top, and then at least two, one on each side, two more on the sides. And it's a lot easier to sand a tab that's on a concave surface like that versus one that's on the inside. So on the inside, you'll need a round sander versus on the outside, it's a lot easier to get a nice clean sand with just a belt sander. So I'm gonna place one right over there and then one on the edge right there. And if you have a tab here that you don't want, you can right click and I believe, nope.
That was interesting.
Yes, don't click cancel because it will, that's not what you want. And so another kind of unfortunate thing is when a toolpath, the setup tab does the same thing. When you cancel an operation like that, before you click OK, it doesn't save anything. So we've got to go back. We're not too far in yet, so go back to tabs. Make it do points. Open up a profile sketch. One here, one here. You can never have too many tabs. I mean, you can't have too many tabs, but it's probably better to have more tabs and be on the safe side than to have too few tabs and it doesn't hold. But with these tabs are fairly beefy, so there really shouldn't be any problems with that. So that is the geometry part right there.
Ethan, could you choose OK at this point and basically save what you've done and then go back into the contour again?
You most definitely can. So if we hit OK there, it'll generate this toolpath with just the default settings with it. You know, it's only taking one pass at this point, and that's not what we want at all. We'll set up multiple passes as we go down. But then, yes, you absolutely can hit OK at that point, then go back and then edit this toolpath, and it'll pop you right back there.
I was just thinking that way after each step, you can choose OK and go back and edit as opposed to trying to do everything at one time.
Yes, that would be a very good practice. And okay, moving on to the heights tab here. This is pretty much what's determining. So you have a couple heights. The clearance height is the max, the top height. The retract height is how high the bit retracts when it moves from one toolpath to another. The feed height is the height off of the top height before it, if you have your clearance height, it'll move over and then wrap it down to the retract height. And then the feed height is when it starts feeding in. The top height is the top of your stock for the most part, where you want the tool paths to start. This top height, and the bottom height is at the bottom of your tool paths. So the clearance, retract, and feed heights are normally pretty good for where you're at. The top height is determined, it defaults to stock top. And when we were doing the setup, when we were doing the stock box there is what determines the stock height. But I find it's good practice to do a selection and then select the top of the model, actually, or anything that's on the top of the model will be the top height, which in most cases the stock top and the top height will be the same unless you're doing a facing operation. And then the bottom height, when it says selected contours, that means the contour that you selected to do the profile, to that 2D contour is the selected contour. And as long as you click the bottom, the selected contours will work, or you can also click selection and then click on the bottom face or a bottom edge of that. And one thing we want to do on the bottom height here is this will be the lowest that the bit goes when it's doing this. And so what we want to do is we want to make this a negative only about 20 or 30 thousandths. We want to make sure that bit clears all the way through the stock. If you have it at exactly the bottom height and you go through, you might, depending on how good your Z touch off is, you might have a little bit of a thinness stuck on there. So it's good practice to make it negative 20 or 30 thousandths, just a hair, to make sure it goes all the way below. Make sure that you don't make sure you have that zero here, because there's a big difference between going 30 thousandths and 300 thousandths down. And as far as the retract height, if you have bolts or Destaco clamps or some kind of fixture holding it on top, it would be good to bump this up to a higher number. So when the bit comes around, it is going high enough to clear part of your setup and fixtures.
Hey, Ethan.
Yes.
So at Sinclair, I'm just going based on what I learned there. This was a couple years ago now. That bottom height, we did it the thickness of the blank. It was like negative 1.7. So what's different this time around?
So what you can do is that selection there that I selected. I selected the bottom edge. You can also have your reference as the top edge.
Got it.
Or a point on the top here, and then make that negative.
Okay. Yep.
Whatever, and then you can see that bottom height plane actually moved all the way down there.
Gotcha.
So it's it's different ways to skin a cat. It's all doing the same thing. It's just whatever you feel more comfortable with and whatever you feel works best for you.
Cool. Thanks.
But for all intents and purposes, it's the same difference, if you will. Yeah. So, any questions? Any more questions about the heights? As far as that goes. All right. We'll move on to the passes. This is the fun part. This is where you really it may seem kind of overwhelming at first because there's a lot of info in these, especially as you click down and open these up. But for the most part, the passes column here is pretty well and set. I'll go through. So you can either climb mill or convention mill in here. Most of the time you want to climb mill if you have a nice sturdy CNC, and it's doing a full width pass. It's doing a contour pass. So climbing conventional isn't really a factor here. We have some finishing passes feed rates. For the most part, outer corner rollover, preserve order both ways. A lot of these don't really affect too much for the kind of toolpath that we're doing right now. With the roughing passes, as you can see, work from the outside in, and we're just doing a straight contour, so we don't need to work with these roughing passes. But we do want multiple depths. This is the tab that we're going to work with. The maximum roughing step down determines how your depth of cut, this is essentially your depth of cut, how much your bit is going to move down each pass. So depending on what tool you're using, it's going to be a little different, but I'll go 1/4 inch. That's a nice step down. It may be, you may want to do a little bit less if you're using a 1/4 inch end mill and you're just tuning it in. For the most part, if you're uncertain about your feeds and speeds, it's always good to make this number smaller, to do a smaller depth of cut, because this really determines, it may take longer to cut out your body, but it is absolutely safer. You won't have any broken bits, or you'll have less tool wear, less friction, less heat up if you're running too slow. So it's always good to start small with this step down and then crank it up as you go along and get more comfortable. The finishing step down will be, we won't do one, but it's how far down it goes. And since we have 0 selected, that won't matter much. Using even step downs is a nice box to check, because it might not be exactly, well, in this case, we're going 30 thousandths under the body. So it'll divide that up by the 7 step downs, because the blank is 1 3/4 inch. So it'll do 7 step downs. But instead of doing 7 1/4 inch step downs and then 1 final 30 thousandths, it'll even them out. And this is a good box to check too, because it makes, you know, all your passes are even and they'll sound the same. You won't need to worry about having one thin one or as you're going through. I know this kind of seems like a lot of stuff thrown at you, but there's a lot of it doesn't really pertain to these tool paths in general. As we go along. And so pretty much the main thing on this tab here though is checking multiple depths and setting your depth of cut here. And so that's about it for the passes tab. When you're doing pockets, I'll kind of go off topic a little bit here. This doesn't pertain to the profile, but the stock to leave tab, when you're doing pockets, like for an operation like cutting the neck pocket, this stock to leave is pretty valuable, because so there's radial stock and axial stock to leave. The axial is in the Z direction, the depth, and the radial is from side to side. So if we set that to 0, so your tool might not be exactly 1/2 inch, or there might be a little bit of play in your machine that causes your pockets to not be exactly the size that you modeled them out to be. Even though you modeled them out to be exactly what you want, there's always variables in the machine that can change that. So this stock to leave is a nice tab. You can even do negative stock to leave. So if you're doing a pocket that needs to be really precise, like the neck pocket, and it turns out to be a little bit wider than you want and it doesn't fit in there real nice, you can do a negative stock to leave, and it will adjust the size of the pocket there. And that's a lot easier to make adjustments on the fly with your machine than it is to have to rechange the model to what it shouldn't be. But yeah, that was a little off topic, but it's still a very, very important tool for doing pockets and such.
Ethan, I'm not sure when the appropriate point is to bring this up, so you decide, but I had questions come up about the relief cut and how that gets assured to be done when you're laying all this out. So at whatever point that's appropriate, might be good to address that too.
Yes, sure thing. I will do this Lincoln tab. There's not a whole lot on here that you need to change. Most of these defaults are pretty good. And I'll show you what these lead-in transitions are. They're pretty much so the bit doesn't plunge right in. It kind of does a little sweeping motion, and you can change them. It's just a little bit easier on the bit to gently sweep in there. But these are all fine. We won't need to worry about ramps right now. The ramp makes the bit slowly ramp into it, and you can select all that. But for the most part, with the tools we're using, we don't need those with the depth of cuts we're using. So that's pretty much it for the 2D contour. So when we click OK, it's going to generate that toolpath, and you'll be able to see all the passes it's going to make. It's going to step down. It's going to get all the tabs, and it's gonna cut out your profile. All right. Yeah, I'll address your question now for the relief cuts. Well, we'll switch back to the design tab. The relief cuts are really important because when you're cutting out this profile here, the bit's cruising along and it's going in a clockwise direction. And what happens when this neck pocket's already cut and you've got a real thin a little bit of material right here. And right now, all of this is material except for this neck pocket. And when your tool's going in a clockwise direction like this, and it's cutting material, it has a very good chance of tearing this grain out and chipping it real good. So what we'll do is we'll edit the profile sketch to have those relief cuts in there. And for the most part, horizontal lines are fine, and they don't need to be terribly long by any means. They just need to be enough to where it removes the material in front of those hard edges. So there'll be a ½ inch of material moved right here. So when this bit's coming along, it's not trying to tear that grain out. So we want to make sure that these two relief cuts coincide with the endpoints of our profile right there. And so with that done, we can finish the sketch. We'll turn this back on and go back into manufacture. And then these will also be a 2D contour toolpath that we use. And almost all of the settings will be the same. What we're going to change, we're going to use the same tool that we use here. But our geometry is going to be different. We're going to want to select both of these for our geometries here. And you want to make sure that the red arrows are on the top side as well. If you put them on the bottom like that, then it's going to cut well into your profile, your transitions here on the neck pocket. So with those selected, we won't need any tabs for this. The heights, like the last one, we want the top height to be on the top of the body, like that. But the bottom height is going to be, and so here's a case where selected contour wouldn't be an appropriate selection for this, because the selected contour is those lines which are also at the top of the body. So we want to do a selection and select a point that is down at the base of the pocket there. So we'll select this line right here. and that will put the bottom height right there at the bottom of that. Which that's what we want, is we want this relief cut to go all the way down to the bottom of the neck pocket, and we can add just a little bit to that so it goes up. So you're not actually cutting into the neck pocket, you're just going just above it. That'll be a good one. And then we can also change our stock top if we have any, our retract height if we have any fixtures that would be in the way. Under the passes tab, we don't need to adjust any of this. Climb milling is fine. We're not really going to do any finishing passes for this because it's just kind of a material clearing, but we do want multiple depths again. But instead of doing a 1/4 inch, we want to make these pretty thin, because with this pocket already cut and the bit spinning, there still is a chance for it to blow out in this operation. But by making a really small step down, maybe 100 thousandths, will greatly reduce that. And we can use even step downs again. We won't need any finishing passes, and the linking is just fine. We'll be fine to plunge right into this. But so with the I was saying, with the transitions on that last, let me pull this up again. With the lead-ins, the lead-in distance and the lead-in radius, I'll show you what those look like on the toolpath. The green bits are the lead-ins, so you can see how it gently comes down into the blue toolpath, and it also, if you look at it in the X, it slowly ramps down as well in 3 directions. That's the purpose of that. And we also want to make sure that it does these roughing passes before it does our profile contour, and you can adjust the order that these do just by clicking and dragging it up. So now you can see, and actually let me rename these to relief and profile, so we know it's what. And then this red is an error, but I think that's just because it needs to be generated again. Yes. So a lot of times when you change something and you don't regenerate the toolpath, it'll say like, hey, something's wrong here. Changes have been made, but it hasn't been recalculated. You can do the relief cuts before the neck pocket. There would be no reason why that couldn't be done. I'm sorry, I missed a lot of this chat. I'm just catching up on it now.
It's all good. Actually, most of the chat questions have been answered as we continue to go forward.
Excellent.
Greg's still got an issue, but we'll work with Greg independently. But thank you, Ethan, because that was a really nice overview of the process, and it was quite concise. As I indicated earlier, you can break it up into the setup process and then the actual tooling operation. The second turn-in item that we're going to ask you to do is this particular file. So you'll then export your model again once you have your toolpaths in it, and we'll be able to see your toolpath generation that occurred, and that's what our final turn-in component is going to be. You don't have to turn in any of the MLA homework. That's for your development purposes and for you to go through and connect the STEM components into the CNC side of things, and to help prepare you for being able to instruct this as part of your future class, whether it's remote or face-to-face. are there any questions or anything that we need to review before we?
Hey, Tom, could you share your screen with the Canvas site open? I want to point out a couple of things.
Sure. Let me bring up Canvas and we'll. I haven't been in Canvas yet today, so we'll do that.
So you can drive while I talk.
Perfect. I'll be happy to. So I will share screen and it will be Canvas and share. Bingo. You should be able to see my Canvas screen as the hybrid CNC.
Yeah. So I want to, there's been some confusion about, you know, what people actually turn in and what they don't turn in and all of that. And so if you recall, there's a lot of information that we put in to this site that we're not requiring you to do, but is just there for reference. So all of that content library stuff that's down there, including there were questions about the speeds and feeds MLA. Where do I turn that in? We're not actually requiring you to do that. We're just listing it there as a reference. So the only thing you're required to do is what's listed in the Summer Institute area. And there are two main areas that you need to be concerned with. One is the creating your guitar body design. So you see that's like the fourth item down. And then there's a bunch of things that are indented to the right below that. And then the second major item is creating the CNC data. And there's a bunch of information indented to the right from there. So those things are all listed kind of in the order that we think they should be done in. So some folks were asking about, you know, order and process. And so we tried to list those things in the order, but also within each one of the categories, we've listed specifically what you should do. So Tom, if you could go to creating your guitar body design, the first major area. So in that, we've just given you a bullet, a numbered list of the things that we are asking you to do. There's also a video that talks you through those various elements as well. And then if you could back up one, Tom, and we'll go specifically to what we've been talking about today, the creating the CNC data. And so once again, there's kind of a list. Those are the two MLAs. We want you to do the what is the G code and the CNC basics. And then we're asking you to watch 3 videos on YouTube, and the links are listed there. And then what Ethan was talking about today, and those are many of the things that Ethan was talking about today. But you'll notice at the very bottom here, there are a bunch of PDFs, and so those are screen grabs showing you the specific data that you're going to be putting into each one of those dialog boxes. So folks are thinking, oh my gosh, I have to watch this video 10 times to get it all. We've actually captured each one of those dialog boxes and the information that you would want to put into those, so you don't have to actually go through each, you know, and start and stop the videos over and over again. But definitely watch the videos for kind of a general overview. That'll kind of repeat what Ethan has talked about and give you specific information there. So we hope that's helpful to you as well. There are quizzes. I saw something come up in the chat real quickly about quizzes. And so as you do the quizzes, they're just going to show up in the grade book. We're not looking at the scores or anything like that. We're just kind of verifying that you're going through the process and doing that. So the only thing that you'll submit to us is your CAD data, and almost everybody has submitted that, and we've reviewed those. And so a lot of times we've reviewed those and given you some comments and asked you to make some corrections, and maybe even provided a video showing you the process for making those corrections. So we didn't mark those complete if they weren't substantially complete, but if they were substantially complete and you just had a couple of little errors, we went ahead and marked those complete for your CAD design data. Also, in a couple of situations, I don't know, probably 3 or 4 situations for me, if there were some substantial issues that needed to be corrected, I went ahead and told you what I did, but I corrected those, and then I posted that finished F3D file in the comments area for the assignment. That way, if you want to, you can just go ahead and use that corrected file to start working on your CNC, and you're not held back while you're still struggling to get your CAD data working. And then you can go back later on and do your CAD data on your own, and we'll be around to help you out with that. But I didn't want you to get stalled and not move on to the CNC tool pathing part. You know, we're running into the end of the week, and you're all going to be busy with the electric guitar next week. So I thought, okay, let's get them moving along. So you have that as an option. And then, and a lot of you have turned in the CNC, I don't know, maybe half, I think. And again, we've made comments on those. Some of the problems with the CNC tool pathing go back to your original design. So there was some issue with your design. So we would make a comment about that and help you along your way. But definitely have a dialogue in that comments area for your submission. That's a good place for us to go back and forth, you asking a question, us answering those questions until, and then you can continue to resubmit new versions of your design and your CNC data as you know, as you see fit, and we'll continue to comment and provide corrective measures for you. So I think that was it. Tom, you got anything else?
Basically, yeah, the whole idea is to have you walk through the whole process, and so you can always spend more time working on and perfecting your design. That's one of the things that your students are going to do, is they're going to over design and underperform on the CNC. They'll want to spend as much time as they can on making designs because it's fun and it's easy, but then when they get to the CNC part, it's a little bit more of a struggle of making sure everything's filled out properly. And so that's where the PDF files come in at the bottom of the page to help guide you through that. The other aspect is set time limits. That's one of the things, Steve, that we probably need to do on this class, is to say that your design has to be done by Wednesday or by Thursday morning. So that way we don't keep working into the design process into a Thursday, Friday kind of a thing. That's one of the things that I found setting up in my class, is setting that time deadline is important.
Yeah, as much as all of you have learned about Fusion, we've been learning about presenting this class online as well. So lots of lessons learned, and we appreciate your patience while we muddle through this.
Ethan, did you have something to say? Or?
Yeah, well, to add on to what you were saying too about not focusing too much on the design, once you get all the tool paths made and everything all set up like that, if you go back and edit that sketch, your profile sketch, everything will update. So like you said, focus on getting the tool paths correct, and then if they want, they can go back, and then any tweaks they make to their design will go back and propagate through their tool paths again.
Absolutely. So the Tuesday session has been emailed, I believe, to all the participants.
Yes.
I know I emailed it out to the team leaders, and I'll do the same here on Friday. So on today's, I will process it this afternoon and email it out to the team leaders later this afternoon, and it should be in your mailbox. It's also available up on STEM Guitar. So if you go to our STEM Guitar YouTube channel, you should be able to find it. It'll be one of the last videos posted up on STEM Guitar. I know that the guitar team is still posting videos and getting ready for their session next week. So it's going to be one of the last videos posted, but it is, I can't remember, I'm pretty sure I made it a public video. So I'll do the same with this one in terms of the settings. So it should be up on our STEM Guitar YouTube channel.
Some people are saying they might have missed it. I wonder if it's because of the email addresses. that they have for Canvas. Some people have two email addresses, one for organization and one for their personal email. If what you have included in your, I mean, make sure you have the email included in your Canvas, and that's where all your information are being sent to.
Yeah, so I will post the so office hour number 1 is now posted. Oops, that went to everybody. I need to do that. So I'll post office hour number 1 in the chat window. Any other questions?
I'd just like to reiterate that everybody keep an eye on your submission. So once you've submitted something, keep an eye on that, because that's how we're responding to you and basically having a dialogue about that specific project.
Yeah, and Jeremy, yeah, you're right. There's a lot of art and design that goes into these guitar models, and in some school districts it counts as part of an art class. Taking our class also, it just depends on how the district breaks up the different sections of the class. Are we going to rebrand as Steam Guitar? Probably not. And it goes back to a little bit of the funding component, because when National Science Foundation puts out requests for proposals, STEM is one of the key components, and hence the reason why we branded it as STEM Guitar is because of the NSF funding request for proposals. Though they are fully aware that it ties all the art, the music, and the science together, which is one of the cool components. And while we have everybody together, one little thing, and I think I mentioned it as part of our webinar originally, is that we've got a partnership with Musiku. It's musico.com. If you want to learn how to play the guitar, this is an online guitar or how to learn how to play the guitar system that he's developed. And so he's offering it free for teachers and the students as part of our project. So go ahead and take advantage of that, and that way your students can build the instrument and learn how to play the instrument along with that particular process with Musiku. So all you have to do is send the email addresses in and you'll get access to Musiku, and just let them know that you're working with us as part of the STEM Guitar project.
All right. Well, keep those submissions coming in, and we'll see you next week for the electric guitar portion.
Yeah, and if you still have some issues with CNC, I know our team will still be around during the electric guitar development also.
Yeah.
So just FYI, if there's a question that does pop up, we can take that offline, and we can hold another Zoom session or another video session. So the Canvas course will remain open during next week also. All right. Well, have a great weekend. We're looking forward to seeing your toolpath designs. Some pretty amazing guitar designs are being created. So that's one of the fun things that we get to see as instructors, is the creativity within the group and all the different designs that people are looking at. And so the next step is being able to cut those designs out and make them real. The advantage of using Fusion 360 is that as part of the Fusion environment, you can also manufacture or 3D print your guitar body, and you can scale it and 3D print a miniature guitar body design once you have that cut out and ready to go as part of that design model. All right, that's all I've got. Have a question for Ethan after your question, Matt. Okay. All right. All right. Well, have a great weekend. We'll look forward to working with you next week on the electric guitars.
All
It's
right.
exciting.
Bye-bye.
Bye now.